Alright, in this video we're going to talk about section 2.2, verifying trigonometric identities. So before we jump in, we should recall that an identity is an equation that's true for all values. So when we said sine squared of x plus cosine squared of x equals 1, that's going to be true no matter what you put in for x. Whereas something like x squared equals 0 is not true for all values of x. It's only true for a certain value, in this case x equals 0. It's not true for 1. 1 squared does not equal 1. But cosine squared of 1 plus sine squared of 1 equals 1. So it's going to be true for all values. Now, much like what we did before when we were simplifying our trig expressions, there's not a set way to do all of these problems, but there are things that are going to happen more often than not. And here's a list of things that we're going to want to do. So we only want to work one side at a time. And it's going to be better to work at the more complicated side first. So what we're going to end up doing in this section is basically what we did last section, except now we know what the answer should be. So we know what we're working towards. So we want to work with the more complicated side first. That's easier so we can take something complicated and simplify it instead of trying to take something simple and making it more complicated. Factoring, adding fractions, squaring a binomial, creating a monomial denominator, all of those things are going to be things that are going to want to look out for. Now, creating a monomial denominator, that's going to happen from multiplying by our conjugate and then using a Pythagorean identity. The third thing, we're going to look for opportunities to use those fundamental identities that we saw in the last section. Most of those are going to be our Pythagorean ones and our quotient ones. So things like 1 over sine being cosecant. If everything before this doesn't help, sines and cosines. Everything into sines and cosines, and that way we can try to simplify from there. And then the key here, the biggest thing, this should really be number 1, is that you need to try something. Don't just sit there and do nothing and stare at your paper. Even if you get the problem wrong, you might get some sort of observation that might help you out in the future. So try something when you're doing these problems. So we're going to do a couple of examples together, and then we'll call it quits on this video. So the first one is we want to verify that secant squared of theta minus 1 over secant squared of theta is, in fact, equal to sine squared. So there's a couple different ways that we can do this. But the first thing that I'm going to is I notice in the top I have secant squared of theta minus 1. That is a Pythagorean identity. That's going to be equal to tangent squared of theta plus 1. So secant squared of theta is going to be tangent squared of theta, and then plus 1, and then we have our little minus 1 here. So our Pythagorean identity is where we can start with on this one. So we have tangent squared of theta plus 1 minus 1, so we're looking now at just tangent squared of theta over secant squared of theta. And we kind of hit a wall, right? I don't want to turn these back into secants because then I just end up right back where I started. So we want to think sines and cosines. So I can turn tangent into sine squared of theta over cosine squared of theta. Over secant is 1 over cosine squared of theta. I have division of fractions, so I can multiply by the reciprocal, so sine squared of theta, sine squared of theta over cosine squared of theta times cosine squared of theta over 1. Cosines cancel, and we're left with sine squared of theta, which is what they wanted us to get. So really, it's just like what we did in the last section, except we now know what our answer should be. We've got to play around with some things, see what happens. So next problem that we're going to look at. Verify that tangent of x plus cotangent of x equals secant of x times cosecant of x. So we want to start with the more complicated side. The left side has more terms. It has 2. This only has 1, so let's start there. We don't have any squares. So we can't go with Pythagorean identities. There's nothing we can factor. There's nothing we can multiply. We're kind of at a standstill right now. So we can go straight to sines and cosines. So sine of x over cosine of x is tangent. plus cosine of x over sine of x is cotangent. We have two fractions. Let's go ahead and get a common denominator and add them together. So the common denominator is going to be sine x cosine x, so this needs to be multiplied by sine of x over sine of x, giving us sine squared of x over sine x cosine x. Plus, this one's going to be multiplied by cosine over cosine, so cosine squared of x over sine x cosine x. Combine them, so we have sine squared of x plus cosine squared of x over sine x cosine x. Our Pythagorean theorem, our Pythagorean identity, tells us that sine squared of x plus cosine squared of x is 1, so we have 1 over sine x cosine x. Looking at our answer, we want secant cosecant. So we can think of 1 over sine of x cosine x as 1 over cosine of x times 1 over sine of x. Use our quotient identity and get secant x cosecant x, which is what we wanted. All right, one more, and then we'll call it quits on the video. We're going to start with secant secant y plus tangent y equals cosine y over 1 minus sine of y. So this one's kind of a toss-up on which one's more complicated, what side should you start with. I'm going to start with the right side, although you could start with the left side and do what we just did, turn them into sines and cosines and kind of see what happens. But I'm going to start with the right side. And I'm going to create a monomial denominator. So I want to multiply the right side by 1 plus sine of y over 1 plus sine of y. So that's going to give me cosine of y times 1 plus sine of y. We're going to hold off on the distributive property and see if we can do something instead, so we don't really have to distribute. Multiplying these, we're going to get 1 minus sine squared of y. So that's not a monomial yet, but we can use our Pythagorean identity to turn it into a monomial. So we can get cosine of y times 1 plus sine of y. And 1 minus sine squared of y is the same thing as cosine squared of y. Now our cosines can cancel, so that's why we didn't want to distribute. So that can cancel with one of our cosines. And that's going to leave us with 1 plus sine of y over cosine of y. Now, looking at our answer, we want secant plus tangent. Now, what we are usually used to doing is if we have something like 1/5 plus 3/5, we're used to writing this as 4/5, right? So in the interim there, what we don't write is 1 plus 3 over 5. So we're really, really good at going in this direction with this process. But what we're allowed to do is work backward. If we have something plus or minus something else over a single term, we can go back, split them apart, and get 1 over 5 plus 3 over 5. So we're basically uncombining like terms. We can do that here because we have cosine of y by itself in the denominator, so we can split this thing up. We can make it 1 over cosine of y plus sine of y over cosine of y. 1 over cosine of y is secant of y. Sine of y over cosine of y is tangent of y. And that's where we wanted to go. So we'll call it quits on the video there. We'll see you in the next one.